In this video, I want to show you how to solve a differential equation, and these are differential equations that we could solve. We could solve this in like 1 minute using all the methods that we talked about in chapter 4, or chapter 4. But I want to talk about how to use the Laplace transform to solve differential equations. So what we're going to do is we're going to solve this differential equation x double prime plus 9x equals 1, subject to the initial condition that x of 0 and x prime of 0 are both 0. So we'll start by taking the Laplace transform of both sides. Okay, so we'll start by taking the Laplace transform of both sides. The Laplace transform of x double prime is s squared, capital X of s, minus x prime, minus s times x of 0 minus x prime of 0, there we go, plus 9 capital X of s. And that's going to be equal to the Laplace transform of 1, which is 1 over s. So this tells you that capital X, let's see, we can simplify a little bit here because little x of 0, x prime of 0 are both 0. So capital X of s is going to be equal to 1 over s times the quantity s squared plus 9. And so now our job is to take the inverse Laplace transform of 1 over s times s squared plus 9. And the easiest way to do this is to do partial fractions. So we can write this in the form a over s plus bs plus c over s squared plus 9. As a review of partial fractions, let's just do this together, but off to the side. I want to figure out if I have 1 over s times s squared plus 9, how do we find the values of a and b so that we can write it in a partial fraction decomposition? So we're going to start by multiplying both sides by the denominator on the bottom left. So we're going to multiply both sides by that quantity. And what we end up with is 1 is equal to a times the quantity s squared plus 9 plus s times bs plus c. And so there's a few different ways to do this. One way to do this is that you can plug in values. And so, for example, if s is equal to 0, that means that we're going to end up with a times 9. Let me write this a little better. We're going to end up with 1 is equal to a times 9. So a is equal to 1/9. And if a is 1/9, that tells us something already. If we want to get the other values, say for b and c, what we could do is we could, there's really two ways to do this. You could plug in values, say 1 and -1, and then what you'd end up with is 2 equations and 2 unknowns, and you could solve that system however you are used to solving linear systems. Or what you could do is there's another way that often doesn't get a lot of love. So let's talk about it. So what I want to do is I want to expand out the right side, and I can write this as as squared plus 9a plus bs squared plus cs. And so I'm thinking of both sides here as a polynomial, a second degree polynomial in s. So what I mean by that is that on the right side, we're going to end up with a plus b times s squared plus cs plus 9a. And on the left side, we have 1, which I'm going to think of as 0s squared plus 0s. And now, if these two polynomials are going to be equal, it turns out that the only way that that can happen is if the corresponding coefficients are equal. So I want 0 to be equal to a plus b. So 0 is equal to a plus b. We would want 0 to be equal to c. So 0 equals c. And then we already know, this we've already talked about, but we know that 9a should be equal to 1. So 1 is equal to 9a. And then this is enough to give us our system. So this tells you that we already know a is 1/9, right? That's old news. B is minus a, so b must be -1/9, and c is 0. I think that's actually easier than plugging in 2 arbitrary values, hoping that nice things cancel. It's really not too much different one way or another. It's really not too much different, but what we're going to do then is we can go back. Now that we have our a, b, and c, we can go back and plug this in. So I want to wall off our work here. So this means that capital X of S, our transform, is going to be equal to A, so it's 1/9 over S, plus BS, which is 1 over 9S over S squared plus 9, plus C is 0, so that C term goes away. Okay, so this is 1/9 over S plus 1/9 S over S squared plus 9. And so now we're able to take the inverse Laplace transform of both sides. This is going to end up being 1/9. And if I have a 1/9 S over S squared plus 9, this will be 1/9 cosine of 3t. Okay, because the inverse Laplace transform of S over S squared plus 9 is cosine of 3t. So there's our solution.